Hey everyone, I want to do a quick rundown on some notes on statistics and just give you a brief overview of this unit we're doing here. First of all, you notice that we're going to start with scatter plots, and we've done this before in the year, so I just want to do a quick refresher here. The x variable means text receives because that is where the x-axis is labeled, and the y is text sent. So the slope here, which is 3/2, means, well, that's delta y over delta x. So we can say the change in y, which is the change in text sent, divided by the change in text received. Well, the change in each of those is really just text sent divided by text received. So you can write it like this: text sent per text received. And then if we look at the y-intercept, that is that point right there. It's 0,3. That means, according to the model, when 0 texts are received, there are 3 texts sent. Now, for the next section, positive-negative association, I want to show you this. I'm hoping to put this at the very end of your sheet here, because this is a great graph to show what correlation and what association looks like. Positive correlation is the same as saying positive associations. That means when one goes up, the other goes up. And a negative association is the same as a negative correlation. So you see, it's just talking about the slope of the line of best fit. This is a positive slope, and this has a negative slope. So if we come back here real quick for positive or negative association, because when x goes up, y goes up, and that has a positive slope right there, then that means we have a positive association. The correlation coefficient is what I would really want to show you here, is how this line that we've got here, and we draw each of these lines, how close the data is to that line is the correlation coefficient. So if it's exactly on the line, it's either going to be +1 or -1, depending on whether it's a positive or negative association. As we get closer to the data points get further away, that coefficient gets smaller and smaller, or rather closer to 0. So that, like this here in the middle, we can't see a clear line of best fit, so the correlation coefficient is 0 because there's no correlation between the data. As you change the data one way, it doesn't necessarily change in a pattern the other way. So we're not going to calculate that. I just want you guys to see how you get those. And yeah, so the correlation coefficient of this is probably something like a 0.8 or so. You can write that down there if you want, about a 0.8. Again, this is really, you're going to have, you're just going to be asked, is it close to 1, is it close to 0, is it close to somewhere in the middle? And this is more close to on the high end, because most of the points are fairly close to the line of best fit there. Correlation versus causation. That correlation is whether it's connected, and the causation means when one makes the other happen. Okay, so let's talk about these two. Umbrella sales increase, the amount of sunglasses sold decreases. I could see those being connected, right? Like if umbrella sales increase, that means it's probably raining outside, so you're probably not going to sell as many sunglasses. So they could be correlated, all right? But there's not a causation there. It's not like because you buy more umbrellas, therefore fewer sunglasses will get sold. It really has to do with maybe a third variable, whether it's raining outside or sunny outside, that's causing those two. Okay, so these we would say there's a correlation, but no causation there. Okay. For the next one, as the number of apps on your phone increases, the amount of memory decreases. That is a causation, because as you download more apps, your memory is going to go down. The downloading the apps is the cause of the memory going down. The third one, a person's income increases, their height increases. That has no relationship at all. There's no correlation there. There's no causation, and definitely no causation. So let's look now and think about the text sent and text received, our graph here. As you send more texts, it doesn't directly cause more text to be received, though you can see that someone who texts more will likely get more responses. So I would consider that I would consider that a correlation, but not a causation. Okay? I'll write that down. Correlation, not causation. All right. So these next words, extrapolation and interpolation. Extrapolation is looking outside of the domain of the data. Okay? So you see the domain goes from 3 to 15, from about there to there. If we pick a point, say 17, way out there on the right, we're extrapolating the data. We're saying, hey, we think our model will continue to work even if you receive more texts than what we got. And you have to think about whether that's valid or not. In this case, if you extrapolate too far, you'll get some ridiculous numbers. Someone could feasibly receive hundreds of texts and yet not send hundreds and hundreds of texts. Extrapolating you have to be a little more careful with. It's a lot safer to interpolate the data. That's when you look within the domain of the data. And so if I pick a point here, say 10, even though you notice that there's no point on the value of 10 right there, there's no point there, we can pick a point and estimate what that value would be, and that's called interpolating the data. So extrapolate and interpolate. Last thing I want you to know are residuals. Residuals are simply how far away, that's the interpolation, yeah. Residuals are how far away the line is from any given point on the scatter plot, and its vertical is the distance we're talking about. So when I'm looking right here, see I just marked the residual. That first point has a residual value of 2. And so you can look at all the different residuals. If it's exactly on the line, like that guy right there, we say it has 0 residual, or the residual is 0 because it's right on the line. So again, just vertical distance from the line. When you make a line of best fit, you're trying to minimize the residuals. You're trying to make the residuals as small as possible because you want as many of the points to be as close as possible to the line. That's why it's called a line of best fit. All right, moving on. We have a histogram, which you guys have hopefully seen here, and just some words to make sure you know. You know that mean means average. So you add all the numbers together and you divide them by how many numbers you have. And I'll let you guys calculate what that value is if you so wish. The median, also known as the middle number, is where you count forwards and backwards and just see which number is in the middle. This histogram is nice for doing that because you can cross out the ends. And I like to cross out one on either side, cross out that guy, that guy, that guy, and you see the middle two numbers are 2 40s. That's in thousands of dollars, so you could say 40,000, but I'll just say 40. So if you have 2 medians, what you need to do is average those 2. Well, fortunately, these are the same number, so there's 2 40s, so the median is still 40. The mode is the most common number. It has the highest frequency, so that here is 40 and 35 because they both show up 3 times. So that's mode. Let me clear that out. You see those show up 3 times there and there. The range is the highest number subtracting the lowest number, the top minus the bottom. And here this would be 60 minus 25, which gives us a range of 35. Standard deviation is a fancy word, and we're going to look at this more. It's just a fancy word for kind of how spread out the numbers are. So if you have a high standard deviation, that means all the numbers are really spread out and far away from the average. If you have a low standard deviation, that means they're all clumped together and you have a bunch right there in the middle, okay? We're going to learn how to calculate this more later, but I just want you to hear about that and see that this has a pretty normal standard deviation because, you got slightly more numbers in the middle, but they also kind of peter off on either side. Now, that's one guy way over here. He's what we call an outlier, and an outlier is a number that's really far away from the others. So in this case, 60 is our outlier because is just very far off from the others. All right, the next one is a frequency table. And the way this works is you see the total here and the total there. There are two different variables. It's called a two-way frequency table. There are two variables we're working with here. One of them is whether you own a cell phone, and the other one is whether the people in this table own a tablet. And you see in this case we have some of the values are filled out, but we need to fill out the rest. And what you need to know for this is that these two totals, this plus this, will add up to that total right there. And we can use that, and I just did, to do 114 minus 37, and I got 77. I can keep doing this because, for example, 34 plus something has to be 77, because these two have to add up this way as well to that total. And so 77 minus 34 is 43. And you can do that for all of these. So these two have to add up to that guy, these two have to add up to that guy, and all I'm doing is I'm using that information and subtracting it to figure out the rest, or in this case, adding these two together to get the 59 there. 55. And it's a good idea, kind of like when you're doing a Sudoku or a crossword, to just double check that last number you enter, make sure it works in your column and your row. And sure enough, 55 is the sum, and 55 plus 59 equals 114. So we're good there. Now, this next part, the marginal relative frequency, the key word here is relative frequency, because we care about our percentage, how often this happens. So if you own a cell phone but not a tablet, that happens 43 times, but it's out of a total of 114 people that were surveyed. That number I grabbed from the bottom right of the table, which is the total of the total. So you divide 43 divided by 114 and you get 37.7%. And we can do that for each of these, and you just get a different percentage. Those four percentages, since we have all four in the middle, those should add up to 100. Now you notice they're a little bit different, and that has to do with rounding. Will be maybe a tenth or 2/10 of a decimal off, but you shouldn't be off more than that. All right, the last chart I want to talk about is the box and whiskers. If you guys didn't know, this is a way of showing the range. So for all the way, the 65 is the lowest, 85 is the highest in this data set. And this middle is the middle 50%, and that line right there in the middle is actually the median of all the data. So what I'm going to do is I'm going to just look at our numbers here, because this is actually a multiple choice problem. And we're going to kind of use the process of elimination to get rid of a few of these options. So one last thing is, if that's the median and that's the middle 50%, then each of those side boxes must be 25%. In fact, all four of these, 1, 2, 3, and 4, have to be 25% of the data. So let's look at this. You see for A, 55 and 90, they're not the correct range, because we're supposed to go to 65 and 85, and so we can cross that data set out. There's also 70 and 80, and part D is incorrect, so we can cross that out, and we know it's got to be either B or C. Now what I'm going to do here is I'm actually going to draw a box and whiskers plot directly on top of our data, just so we can look at it a little closer, and you see a lot of it looks pretty good. I don't like that 81 right there, because 81 should be outside of that middle 25%, but there are 8 numbers there, and 25% of 8 numbers is 2 numbers. So both of those 2 numbers need to be between 75 and 80, and that's not true for B, so B cannot be the right answer. Let's break down C a little bit more, just to make sure we're convinced that that's correct. I'm going to draw the box and whiskers again, and if you notice, I've got the average between those two, between 69 and 71, is 70, and that falls right on the average that I wanted there for that 70 there. Also on the right, 78 and 82, the average of 78 and 82 is 80, and that average falls right there on the other average that I'd like. So this, I'm pretty convinced, is my data set, and I like how it looks. Thank you guys for watching, and I hope you learned something and or remembered something about statistics.